Hi students, welcome to my lectures on thermodynamics. In our last class, we have discussed about different processes like constant volume process, PV equal to constant process. And today we are going to discuss about some other process which is called polytropic process. And let us see what exactly the means, because finally our objective is to find out how much work is expended in this expansion process, that is from the state P1 V1, that means from the state 1, okay, from the state 2, okay, P2 V2. If you look into this graph, the top one is called, if it is a horizontal line, then it is called the constant pressure process, because here the pressure is not changing, only volume is changing. Pressure remains the same. In n equal to, if you follow this vertical line, here the volume is not changing, only the pressure is changing. The volume remains the constant, because this is called constant pressure process, this is called a constant volume process. In between the constant pressure process and constant volume process, different process exist, okay. That different kinds of processes we represented in terms of polytropic process, okay. And in general, the polytropic process is represented by this equation PV power n equal to constant. Earlier in the previous lecture, we have discussed what is the process which is called PV equal to constant. Here now P into V power n equal to constant. That means the line, okay, which is the line equation is nothing but PV power n equal to constant, because along this line the PV power n, okay, this remains the same. That means P1 V1, the initial state P1 V1 power n, which is equal to P2 V2 power n, which is equal to PV power n, which is equal to constant. But along this line, and these equations should valid. That is what the equation of these lines. N here signifies polytropic index. N value varies, okay, from n equal to 0, between n equal to 0 to n equal to infinity, okay. The value of the n will varies. Depending upon the value of the n, the curve is going to change. Here it is n equal to 0 and here n equal to infinite. As you and n value increasing, the curve tends towards the bottom, okay, shifted towards the vertical line. So let us use the concept of PV power n equal to constant and evaluate the displacement work. As we have discussed, the displacement work is represented by minus integral volume V1 to V2 P into dV, okay. So this is the P1 V1 is the state 1, P2 V2 after the expansion it is the state 2. So using this equation, that is P1 in place of P, I substitute P1 V1 power n by V power n, okay. That is what, in place of P, I use these two terms, and what is P? Nothing but P1 into V1 power n by V power n. So if I represent this and evaluate the integral, as you know, P1 V1 power n equal to constant. If it is a constant, it comes out of the integral. If it comes out of the integral, then displacement work is equal to minus P1 V1 power n into V1 to V2 1 by V power n into dV. As you know, 1 by x power n into dx. If you remember the integral of 1 by x power n into dx, you get to know these terms, how I got the volume, okay. The V will go to the numerator, then it becomes V power minus 1. Now x power n integral nothing but x power n plus 1 by n plus 1. So this integral will become V power minus n plus 1 by minus n plus 1 from the limits V1 to V2. If I substitute the limits, you get the equation that WD is equal to P1 minus P1 V1 power n into V2 power n 1 minus n into V1 power 1 minus n by 1 minus n. If I take this minus symbol to the bottom, this 1 minus n will become n minus 1. So finally, the displacement work can be calculated as P1 V1 power n by n minus 1 into V2 power 1 minus n minus V1 power 1 minus 1. So that means this equation is used if you know initial pressure, initial volume and final volume. What if you don't know this? what if you know what is initial pressure and final pressure, initial volume? So in such cases you cannot use this equation to calculate. This equation you can use only if you know P1, V1, V2. If you don't know P1, V1 and V2, you cannot use this equation to calculate the displacement work. Now let us switch the volume terms to the pressure terms now. So let us do some mathematics behind it. So take this same equation, take this P1 V1 power n into this term. So 1 by 1 minus 1 is P1 V1 power n into V2 power 1 minus n minus P1 V1 power n into V1 power 1 minus n. Okay, you know P1 V1 power n is nothing but P1 V1 power n is nothing but P2 V2 power n. So in place of P1 V1 power n, here from the first term I change it to P2 V2 power n, because I bring everything in terms of state 2 and everything here in terms of the state 1. So if you do this, finally you get WD is equal to 1 by n minus 1 into P2 V2 minus P1 V1, because here the things got cancels out. Here n minus n cancels out, here n is minus n cancels out. That means you can use either this equation. Now the new equation has come. Displacement work can be calculated as 1 by n minus 1 into P2 V2 minus P1 V1. Here you can use this equation only if you know P1 V1 P2 V2. If you know initial pressure, final pressure, initial volume, final volume, then only you can able to calculate the work, displacement work that has been done. So still let us change this equation further in terms of only pressures. Okay, here is only in terms of volume mainly. Here pressure and volume both are involved. Now let us change it to only pressure. Now I take out from these two P1 V1, I take out as a common. Then what happens? This term will become P2 V2 by P1 V1 minus 1. So here you can see, let us change this V2 by V1 in terms of pressures. As we know the relationship P1 V1 power n is equal to P2 V2 power n. From this mathematics, V2 by V1 is nothing but P1 by P2 power 1 by n. That means in place of V2 by V1, I replace with the P1 by P2 power 1 by n. Okay, if you do that, displacement work is nothing but P1 V1 by n minus 1 into P2 by P1 1 minus 1 by n. So here it is 1, it is minus 1 by n, and it has become 1 minus 1 by n. So if you take out the least LCM, P1 V1 by n minus 1, now it became n minus 1 by n minus 1. See now, here now maximum in terms of pressure, here only in terms of volume, the difference in volume. Here you should know the pressure and volume, the difference both. Here you need only pressure information is required, initial pressures and final pressures. Okay. So let us, because you can calculate the displacement work either by this equation or by this equation or by this equation. Any equation is fine. Everything comes to the only one single solution. Let us have some example. Calculate the displacement work in an expansion process. Here to here expansion process. Given initial pressure is 1000, initial volume is 1 meter cube, final volume is 2 meter cube. The polytropic index is given as n equal to 2. If this is the case, let us use the equation number 3 to find out what is the displacement work. So displacement work is equal to P1 V1 power n by n minus 1 into V2 power 1 minus 1 by V1 power 1 minus n. So let us, if you substitute each and every term, pressure 1000 into initial volume power n by n minus 1 into V2 power 1 minus n minus 1 power 1 minus n. So if you do that, minus 500 joules you have got. Why you have got minus? It is very reasonable, and it is because it is following the sign convention, because it's an expansion process. System has something done on the surroundings. Because of this expansion, this system has something on the surroundings. Anything system will done on the surroundings, it should be negative. So that is why you got the minus 500 joules. And you know, I mean, initial pressure you know, initial volume you know, final volume you know. What is the final pressure? You can use the further I mean the same problem, if you do the further, I use the relationship P2 V2 power n is equal to P1 V1 power n. From this, P2 is equal to P1 into V1 by V2 power n. Therefore, the P1 is equal to 1000, V1 equal to 1, V2 equal to 2, whole power n, which is square. 250 pascals. You can see what is the initial pressure. Here it is 1000. After the expansion, the pressure has dropped, volume has raised. How much the pressure has dropped? 250 pascals. How much the volume has raised? 2 meter cube. So this is what, how to calculate the work, that mainly the displacement work during a process which is called polytropic process, with the polytropic index which is equal to 2. Okay, I hope now you have learned, what is the polytropic process. We get in the next lecture, I will try to cover, it's an adiabatic process. It is very simple. Okay, thank you very much. See you in the next lecture.